The first questions on this revision sheet deal with index notation. So first we have to write these in decimal notation. If we just have a look down here, decimal notation is like this, perhaps what we would call normal numbers. Index notation is this way. So there are a couple of ways that we can think about this. 3.12 by 10 to the 2. 10 to the 2, 10 squared is 100. So 3.12 multiplied by 100 is 312. Or we can say 10 to the 2 means we have to move the decimal place 2 spaces, making it a big number. A bigger number, I should say. So the answer is 312. Similarly for this one, 6.1 by 10 to the 5. We can do that by saying, okay, we're going to have to move the decimal place if we make it 61, that's 1 space, 2, 3, 4, 5. So our number is 610,000. If we want to check it, we can say, okay, let's move the decimal places back and check that it's by 10 to the 5. We go 1, 2, 3, 4, 5. We get 6.1 by 10 to the 5. Now we move into where we've got a negative indice by 10 to the negative 1. That means we're going to have to move the decimal place one direction that makes it a smaller number. So that's going to be 0.122. The other way to remember it is 10 to the negative 1 is in the tenths column, which is here, so 0.122. Equally here, (1.5 by 10 to the minus 5). So we're going to have 10 to the minus 4. We're going to have to move this decimal place a number of places towards the left. So if we start at 0. By the time we put the 1 in there, that would be 1 decimal, 1 space, 2, 3, 4, 1, 5, 2. So we've effectively moved the decimal place 1, 2, 3, 4 spaces to make it a smaller number. Now, going in the opposite direction, 54. To make it 5.4, we're going to have to move the decimal place 1. So when we're writing in scientific notations, we always start with one number before the decimal point. So in this case, 5.4 by 10 to the 1. Because we've moved the decimal place 1 to make it 5.4 by 10 to the 1. Now we start with one number in front of the decimal place. So it's going to be 4.0, sorry, and we have to move it 1, 2, 3. 4.4 by 10 to the minus 3. And the last one, we're only going to have to move the decimal point 1 place there. So this will be 1.24 by 10 to the negative 1. We moved it 1 place in a negative direction. Okay, now we bring in the idea of significant figures. So when we look at significant figures, we look at the first number that's got an actual number there. So there's the 1. We say we've got correct to 3 significant figures, so 1, 2, 3. We go 3 figures along, which is the 4. And then we look at the next figure and say, do we round it up or do we stick at 4? Because it's a 5, we round up. So this way we're going to be writing it's 1.35. That's the third significant figure that we've rounded up. And to work out our indices, we've got to move it by 10 to the 3. To give us the correct answer. We know 10 to the 3, that's thousands. So it makes sense. 1.35 by 10 to the 3 is the right thing here. Now we've got two decimals. We're going to think how far we've moved them and what it's going to be when we go to the third significant figure. So as we come down, these zeros are just placeholders. So 5 is the first number, first, second, third. So we look at that third number as the 2. The fourth is the 4, so we don't round up. So our significant figures are 5.12, 10. We know it's a negative. How negative is it? 1, 2, 3, 4. We'd already done that by 10 to the negative 4. Now, this is interesting because it looks like almost the same number with difference to the end. So we're going to go to 3 significant figures, 5.12. In this case, the number after the 2 is the 6. So we round that up. It's going to be 5.13 by, and we've already done this maths. We can do it again here just to double check. 1, 2, 3, 4 by 10 to the minus 4. So even though the same numbers to the 3, it's just the rounding the significant figures that make a different